this slide. So now once we know how to make a display to be readable outside, so we know that we can increase the brightness or we can decrease the reflections, and we have the image that we can see, we need to think how to make the display to operate outdoor, yes? And this is all about the temperature. So as you know, our standard operating temperature displays that we offer are -20 to 70. I would say this is industry standard. This is like standard operating temperature. And the storage, of course, is a little bit higher. Actually, some of our displays, for example, 7-inch for sure was tested like -30 to, as I remember, I think 80 or 78 degrees. It was working, yes? So the real practical value is even higher, but this is what we guarantee by spec. But for real outdoor LCD, it's too low. It's too low on two ends. So -20 in many cases is not enough. Maybe -30, -40 would be good enough to like have outdoor display worldwide, yes? Maybe, you know, in Scandinavia or somewhere else, we may expect lower temperatures than -20. And on the high end, it's also a problem because if we are outdoor in the summer and we have a direct sunlight, the surface of a display can go higher than even 70 or 80 degrees, yes? So we need something different, and we need actually different technology, because what is happening here with a typical LCD, we have this liquid crystal. Liquid crystal, it needs to be liquid to work, and below this temperature it starts freezing. That means, like, you know, becomes solid, and the crystals cannot move or move very slowly. And above this temperature, it changes the phase. Yes, so the phase that we work normally, like in this range of temperatures, let's say -20 to 70 degrees, we have the phase that we call nematic. So nematic phase is a phase where the light can be operated, let's say, by a crystal. So as you remember from discussion about how the LCD works, liquid crystal has the ability to change the polarization of the light, but it needs to mechanically move the crystals inside this liquid crystal cell, and it needs to be in this nematic phase, yes? So below that we become solid, we cannot move, and above that, if we go, let's say, above 70 or 80 degrees for typical display, sometimes the border is only 50 degrees for consumer grade products. If we will go to isotropic phase. And isotropic means you cannot change the polarization of the light anymore. It becomes like all the light can go through this liquid crystal, and you cannot control it anymore with the voltages or anything. So basically you can't like switch on and off pixels, yes? That's why we have something that we call high Tne displays, and it means high, yes, Tn, which is like, you know, twisted nematic, nematic isotropic. So this point, nematic to isotropic, we want to put as high as possible. So for consumer, it will be maybe 50 degrees. And we will go from nematic to isotropic. That means the display stop to work. For industrial, will be 70, yes? And what we need is higher. And there are technologies, we call them high Tne technologies, that move this point even higher. And we should have it, yeah, for outdoor displays, marine, yes, automotive and military. And this is example from a UO presentation about high Tne displays and outdoor displays basically. So we have two cells, two liquid crystals that we can use. One is like -20 up to 110 degrees, and the other one, the latest one, is -40 up to 110. So the same upper temperature. So in this range we are safe. So we can go very low with the temperature and it will not become solid, and we can go very high with the temperature up to 110 degrees and it will not become isotropic. So the display will be working. Maybe you have seen some displays that were used to outdoor, are used outdoor, and sometimes they become black. We call it the blackening effect. If they become like too high, that means the crystals become isotropic, and you can see maybe the part of the display is black or the whole display become black, depending on temperature. The good thing is that it's not breaking the display, so once the temperature drops, it go back to the pneumatic phase and the display work again, but in a high temperature you cannot see anything on the display. It's basically is not working, yes? So if you will go to the roadmap of AUO, for example, you will see which exactly displays has this, high temperature liquid crystal, yes? High Tne LC, we call it, so high temperature pneumatic isotropic liquid crystal, to be precise, yes? So you can see which ones you can use in outdoor environment. And here we have example from a data sheet of a display with high temperatures. So as we said, it's a liquid crystal from -20 to 110. So this is the latest technology, but you need to be careful. This is only about the surface of a display, so a TFT glass itself. So we can have the sunlight going to the display and increase the temperature of the display, but the whole display as a module, we need to be careful. And in, let's say, the operating temperature, depend on the display, of course, can be lower, can be as low as 0 to 50 or -20 to 70. So we need to control that. Maybe we can have two temperature. What does it mean? That means if we will use this display outdoor, we are safe from the sunlight. The surface of the display can go very high, but maybe our ambient temperature inside our housing, yes, because we have some kind of enclosure. Let's imagine it will be a totem or something. Inside we need to control the temperature to not go too high, yes. Maybe 50, 70 will be maximum. So there are usually maybe a fans inside to remove the heat from inside or something like that. But in typical use case, we have a computer inside and we have more devices that cannot work with that high temperature as 100 degrees. So we control this temperature anyway, yes? So it's not so bad. This temperature just cannot be too high inside, and for sure cannot be that high as a liquid crystal itself can withstand, yes, which is 110 degrees, yes. So that will be all for today about the control.